to another episode of Candy Love. Okay, so today we're going to discuss about covalent bonds. So, guys, do you have any idea about covalent bonds? So, a covalent bond is a chemical link between two atoms or ions where the electron pairs are shared between them. The term covalent bond first came into use in 1939, although Irving Langmuir introduced the term covalence in 1990. There are two important types of covalent bonds, which are polar bond and non-polar bonds. So non-polar bonds occur when atoms equally share electron pairs. As the electronegativity difference increases, the electron pair in a bond is more closely associated with one nucleus than the other. If the electronegativity difference is between 0.4 and 1.7, the bond is polar. If the electronegativity difference is greater than 1.7, the bond is ionic.
Formation of covalent compounds. Have you ever played with two magnets? Positive end of one is attracted to the negative end of the other. A similar thing happens during the formation of covalent compound. Atom is made up of the positive nucleus and the negatively charged electrons that surrounds it. Each of these fluorine atoms only need one more valence electrons to complete its outer shell. When the atoms bond by sharing two electrons, it will form a single bond. This isn't always the case, however, some of atoms are more electronegative than others. So what did you mean by electronegativity? Electronegativity is the ability of an atom to draw electrons to itself. An even share results of formation is called dipole. What did you call the dipole? Dipole is a pair of equal and opposite electric charge or magnetic poles of opposite signs separated. One of example is hydrogen fluoride. Hydrogen fluoride is a simple covalent compound that has a dipole. The fluorine is an extremely electronegative compared to the hydrogen. In this image, you can see that the fluorine has a partial negative charge and the hydrogen has a partial positive charge. Covalent bonds are formed when two atoms share a pair of electrons. These atoms of similar electronegativities are generally non-metallic. Double bonds form when the atoms share two pairs of electrons. Triple bonds when they share three pairs of electrons. The reason why covalent bonds are formed is that it allows each atom to attain a noble gas electron configuration which is extremely stable.
Molecules of elements. So first, what is molecule? Molecule is the smallest unit of chemical compound that it exhibits the same chemical properties of the specific compound as elements. Element is the fundamental substance that consists of only one type of atom. Elements consist smaller particles and can be made man-made or synthetic. Their arrangement in the periodic table is based on the number of protons in an increasing order. When atoms are arranged differently in an element having the same number of protons, you get different forms of an element. For example, both graphite and diamond are elements of carbon, but they look different from each other.
Formulas for molecular compounds. Molecules consist of two or more atoms bounded to one another through covalent bonds. Identification of these molecules is through their molecular formulas. There is a hierarchy of formulas. 1. Empirical formula. The empirical formula expresses the most simple ratio of atoms in the molecule. Consider the benzene molecule which has 6 carbon and 6 hydrogen atoms. Therefore, the ratio of carbon to hydrogen atoms is 6 to 6, which we can simplify to 1 to 1. Therefore, this image that we can see now, benzene has 1 atom in carbon and 1 atom in hydrogen. The structural formula. The structural formula not only has the correct number of atoms but includes the bonding structure of the molecules. Like this image, the methane that bonded and the benzene is bonded also, ethane, acetic acid, and water. And we were now in 3D structural formula. Molecules are 3D objects. The 3D structural formula is an attempt to convey the geometry of the molecule. And this is the example of 3D structural formula. If you need to use a structural formula for represent that 3D molecule. Space filling formula. The space filling formula includes the relative sizes of the atoms. For example, the molecule acetaldehyde C2H4O. And this model, the gray, which represents the spheres of carbon atoms, and the yellow, hydrogen, and the red is oxygen. We will use it by predicting the sizes of atoms.
Lewis structure is a graphic representation of electron distribution around an atom. It shows the bonding of atoms in a molecule and the lone pairs of each electron. It predicts the number and types of bonds formed in each atom. Lewis structure is used to represent covalent bonds. Remember, the covalent bonds are stronger than electrostatic interaction of ionic bonds. But keep in mind that we are not considering ionic bonds as we go through this chapter. Lewis structure is based on a concept of octet group, in which the atoms share electrons so that each atom has 8 electrons and 8 atoms. The most effective way to get a correct Lewis structure is first to write the Lewis diagram that involves all the atoms and the bonding and the adding of the total number of valence electrons that are available for the bonding. One good example is the water molecule, which is in a chemical formula of H2O, which means that we have 2 hydrogen atoms and 1 oxygen atoms. And in this case, the central atom would be oxygen. Each of the 2 unpaired electrons in the oxygen atom will form a bond with one of the paired electrons of the hydrogen atoms. The bonds formed by the shared electron pairs can be represented by a straight line between elements and symbol.
I was talking about the structure and properties of a molecular compound. There are 6 properties of covalent compounds. First is, most covalent compounds have relatively low melting points and boiling points. While the ions in an ionic compound are strongly attracted to each other, covalent bonds create molecules that can separate from each other when a lower amount of energy is added to them. Therefore, molecular compounds usually have low melting points and boiling points. Second property is covalent compounds usually have lower enthalpies of fusion and vaporization than ionic compounds. The enthalpy of fusion is the amount of energy needed at constant pressure to melt 1 mole of a solid substance. Third property is covalent compounds tend to be soft and relatively flexible. This is largely because covalent bonds are relatively flexible and easy to break. The covalent bonds in molecular compounds cause these compounds to take form as gases, liquids, and soft solids. Fourth property is covalent compounds tend to be more flammable than ionic compounds. Many flammable substances contains hydrogen and carbon atoms which can undergo combustion, a reaction that releases energy when the compound reacts with oxygen to produce carbon dioxide and water. Fifth property is when dissolved in water, covalent compounds don't conduct electricity. Ions are needed to conduct electricity in aqueous solution. Molecular compounds dissolve into molecules rather than dissociate into ions, so they typically do not conduct electricity very well when dissolved in water. Sixth property is mainly covalent compounds don't dissolve well in water. There are many exceptions in this rule, just as there are many salts, which is ionic compounds that don't dissolve well in water. However, many covalent compounds are polar molecules that do dissolve well in polar solvent, such as water. Examples of molecular compounds that dissolve well in water are sugar and ethanol. Examples of molecular compounds that don't dissolve well in water are oil and polymerized plastic.
So let's start with molecule. So molecule is a general term used to describe many atoms that are connected by chemical bonds. Every combination of atoms is a molecule. A compound is a molecule made of atoms from different elements. All compounds are molecules, but not all molecules are compounds. Hydrogen gas, or H2, is a molecule, but not a compound because it is made of only one element. Water, or H2O, can be called a molecule or a compound because it is made of hydrogen and oxygen atoms. There are two main types of chemical bonds. The first one is the covalent, and the other one is the valence bond. Atoms that share electrons in a chemical bond have covalent bonds. An oxygen molecule is a good example of a molecule with a covalent bond. Ionic bonds occur when electrons are transmitted from one atom to another. Table salt is a common example of a compound with an ionic bond. I hope that you've learned a lot about covalent bonds.